Solve problem 7.5. Center of mass of a long thin rod. A long thin rod lies on the x-axis. One end of the rod is located at x equals 1 meter and the other end of the rod is located at x equals 3 meter. The linear mass density of the rod is given by lambda equals ax squared plus b, where a equals 0.3 kilogram per meter cube and B equals 0.6 kilogram per meter. What are the mass of the rod and the x coordinate of its center of mass? So here in this question, we have a thin long rod which stretches from x equals 1 meter to x equals 3 meter. And they have given me the linear mass density of the rod, which is lambda equals ax squared plus b. We have the values of a and b, which we can substitute here in lambda. A is 0.3 x squared and b is 0.6. In the first part of the question, we need to find the mass of the rod. So in continuous mass distribution in one dimension, if they give you the linear mass density, you can calculate the total mass by integrating the mass density over the distance x. So we write the mass capital M to be equal to integral lambda dx, where x values goes from initial to the final point. This will be equal to integral. My rod extends from x equals 1 to x equals 3 meter. So we will write the limits of integration going from 1 to 3. Lambda is 0.3 x squared plus 0.6 dx. Then we integrate the terms. We get m equals, since 0.3 is a constant, we keep it as it is. When you perform integration, you increase the power of x by 1. So x to the power 2 here will become x to the power 3. And then we divide by the new power, which is 3. Plus, now 0.6 is a constant without x. So power of x for this particular term will be x to the power 0. So when you integrate, you will increase the power of x by 1. So x to the power 0 will become x to the power 1 and we will get integral of this term to be equal to 0.6 times x. Then we substitute the limits. We have to do upper limit minus the lower limit. So first in place of x, we will substitute the upper limit, which is 3. Then in place of x, we will substitute the lower limit, which is 1. So we get 0.3. In place of x, we write 3 cube over 3 plus 0.6 times 3 minus, now in place of x, we will write 1, 0.3, 1 cube over 3 plus 0.6 times 1 will give me just 0.6. And when you solve this, you get the mass of the rod to be equal to 3.8 kilogram. So anytime they give you linear mass density, you can find the total mass of the object by integrating the mass density over the distance. Now in the second part of the question, they want us to find the x coordinate of its center of mass. So for any continuous mass distribution in one dimension, you can find the coordinate of center of mass by using the rule x equals 1 over m integral x lambda x dx, where you integrate from the initial and final position of the rod. So we will substitute the values here. The mass m in the previous part, we found it to be 3.8. So we write 1 over 3.8 integral. The rod is extending from x equals 1 to x equals 3. So we substitute this as 1 to 3 x times lambda, which is 0.3 x squared plus 0.6 dx. So the first thing we are going to do is multiply this x with the terms inside before we integrate it. So we get integral 1 to 3 x times x squared will be x cubed. So 0.3 x cubed plus x times 0.6 will be 0.6 x. And then we have to integrate this down. So we get 1 over 3.8. 0.3 is a constant, so we keep it as it is. Now when you integrate, you increase the power of x by 1. So x to the power 3 will become x to the power 4 over 4 plus 0.6. X to the power 1 will become x to the power 2 over 2, going from 1 to 3. Now we are going to substitute the limits. So we have to do upper limit minus the lower limit. So you get 1 over 3.8. First, in place of x, we will substitute the upper limit, which is 3. So 0.3, 3 to the power 4 over 4 plus 0.6, 3 to the power 2 over 2. Then in place of x, we are going to write the lower limit. So minus 0.3, 1 to the power 4 over 4 plus 0.6, 1 squared over 2. And when you solve this, you get the x coordinate of the center of mass to be equal to 2.21 meter.